Hi guys, in this lesson I will tell you everything you need to know about tessellation in computer graphics in general and in CAD systems specifically. On top of that, I will show you the issues tessellation may produce and how to solve these issues. There will be a lot of theory, so if you're interested in practical examples, use timestamps. So, what is tessellation? Now, depends on the subject, it may have different descriptions. We are interested in computer graphics, and in computer graphics, CG for short, tessellation refers to the process of subdividing a mesh into smaller geometrical shapes without overlaps, usually to increase the detail or smoothness of a model. And I want to bring your attention to the word mesh. What is mesh? Mesh is a collection of vertices, edges, and faces that define the shape of a geometry in 3D space. There are a couple outliners to this description, like parametric meshes, voxels, grids, and point clouds, but overall, it is safe to say that mesh is a polygonal representation of geometry, and this is extremely important for everything that comes next in this lesson. So, as you can see, I'm in the Blender now. I will get to Alias soon enough, but let us start discovering principles of tessellation in its natural habitat. On my screen, you see a sphere, this one, or better say its approximation. It is a mesh, a polygonal representation of geometry in 3D space, and it is heavily discretized. In polygonal modeling, it is quite a normal thing to see, and in the process of modeling with polygons, the less geometry you have, the easier it is to model. But eventually, you need to ramp up the details, and you need to bump the complexity up. For example, making these somewhat a sphere looks more like a real sphere. And the way to do it is to use tessellation algorithms. One of the most prominent in polygonal modeling is an algorithm called Catmull-Clark. It was designed by Edwin Catmull and Jim Clark in '79, a long time ago. They even got some math award for that. An interesting fact, by the way, it was originally designed to tessellate NURB geometry, and we will talk about it, but become a standard in polygonal modeling environments instead. So what I will do is I will apply it to my sphere. So I'm going here, and I will apply a subdivision modifier with Catmull-Clark activated. Here we go. So as you can see, this algorithm ramped up the complexity by subdividing a mesh without overlaps on a smaller chunks and smoothed out the model. That is what subdivision modifier under the Catmull-Clark tessellation algorithm does. It is still faceted, but we can easily recalculate normals and the form will become smooth. Let me actually show you. So I will shade it smooth, and now it's smooth. So let me just preview this in render. Now, in CG, subdivision, tessellation with Catmull-Clark, and normal calculation is a universal evaluation procedures used by all polygonal-based 3D software packages. So it is true to Blender, Cinema, Max, Maya, Code, ZBrush, and the list can go on and on. Now, polygons are discrete at its nature because faces, pieces of a model are finite in detail. In fact, they are always planar parts. So let me actually apply it and see the model. So now, as you can see, there is a lot of polygons, but every single one of them is actually a flat piece. Now you can tessellate this object to extreme, and it will appear smooth. But on fundamental level, it consists from flat parts. And this is a big drawback and a big benefit at the same time. Now you may ask me, why are you telling me all of this and spending my time on polygons when I'm modeling using infinitely accurate NURBS geometry? Well, let us go to Alias now, and I will show you why. So, right? Okay, Alias. So, let me just activate the proper layer, like that. So, you are looking at a sphere in Alias. This sphere is mathematically perfect. Its circumference is perfect, its radius is perfect, it's under the rational flags. I made a video about the rational flags, by the way, so if you do not know what rational flags are, I will put a link in the description. So it is perfect, it is NURBS. Why it's so discretized then? Like, look at this. Now, you may say, well, that is the quality of render, right? Yes and no. If you look closer, let me just zoom in a little bit. Maybe somewhere here. Oops. I think like that is good enough. So, if you look closer, you will realize that its appearance is somewhat similar to the appearance of a polygonal sphere I made in Blender. And on top of that, if you open up the shader, let me just open up the shader. I'm already here. So here's my shader. This is just the default shader. Where is the parameter? Oh yeah, here it is. So where was I? So yeah, if you open up the shader, you will notice that, well, there in this panel there is no such thing as a quality slider. Instead, there is two others. One of them called tolerance, and another one called tessellator. It's set to accurate. Now, the reason why there is no quality slider, because, well, how can it be? Polynomials are polynomials. You can't make them less accurate. I guess at this point you add 2 and 2 and already figured out where it's going, right? So let me make a big reveal until it completely spoils. What you're looking at in Alias is not a NURBS geometry. It is a mesh, a polygonal model. And it is not only true for Alias, it is true for every single CAD system in the market. You never see NURBS geometry, you see mesh instead. Well, first question you may ask is why? Second, how? And third, what's about it? Is it a big deal? Well, why is quite simple. NURBS geometry is too complex to visualize. We actually do not have a good solution to visualize something infinitely accurate on a computer. And extremely smart people found an elegant solution to this problem decades ago. Discretize NURBS geometry by converting it to a mesh. It is a simple process in terms of computation, so it happens real time. So how it is done? In simple terms, there are 4 steps. Now the first one, I'm just going to zoom out. Now the first one is parametric representation. So Alias builds an underlying math structure of NURBS geometry that created by your inputs. So I created the sphere here, it took my input, it created an underlying math structure of NURBS geometry. Second is evaluation. Surfaces will be evaluated at numerous points along a parametric domain of NURBS. NURBS, as you probably know, a two-dimensional domain of points that defined by polynomials. This means calculating the precise positions of the surface for a grid of parameter values. And the third is polygonal approximation. These evaluated points in the step 2 actually connected, after that they then connected to form a mesh of polygons, usually triangles, but not necessarily. It depends on the algorithm. Now, this step approximates the smooth NURBS surface with the piecewise linear surface, which is a tessellation process, basically. And fourth is the refinement. So the density of the tessellation, which means the number of polygons, can be controlled to balance between well, let's say the visual accuracy and computational efficiency. So higher density tessellation will yield smoother and let's say more detailed surfaces, but require more processing power. And that's exactly what you're going to do, what you will do when you move the tolerance slider. So this is the tessellation slider, actually. So in the end, this process allows the curved surfaces defined by NURBS to be visualized and manipulated, so modeled, using the polygonal meshes. That, let's be honest, the staple of real-time graphics in most 3D modeling applications. Essentially, it's about finding a practical middle ground between mathematical precision and graphical efficiency. And now we come to the practical question. What's about it and why it is important? Let me show you. Let me actually hide this sphere now, and I will open up this example, this surface. Let me just turn that off, and let's just increase the tolerance to like something more manageable. Right. So you probably, if you watched my previous lesson about three-sided patches, you're familiar with the example. Now this is the flawed example. It have an issue because there is a degenerate point on the top, specifically on here. So if I'll select, you're going to see there's a few CDs. And I mentioned that the reason why the surface will have problems visually, and let me just zoom in and you can immediately spot them. Here they are. You see this strange oddities in the surface. And not only here, the full surface is kind of wrong. Now the reason for that is because these CV multiplicity, the degenerate point is just causing issues in the underlying math structure of the NURBS geometry, of this NURBS surface. But on top of that, it butchers the geometry on tessellation process. As we already discussed, this is, what you're looking at, is a mesh. And what will happen with the mesh when you overlap vertices? Exactly, you will have geometrical issues, you have visual issues, you have normal issues, all kind of issues you may have, you will have. And this is additional reason why you have this problem. Now let's see another example here. It's a little bit more interesting actually, even though that's quite simple. So I'm just activating the standard multicolor shader, this default shader. And from the general scheme of things, it looks fine. There is no issues, right? But if I will zoom in, oh, what's going on? Look at this stuff. So I will see the difference in color from the top and from the bottom. Interesting. What's actually going on here? Now, is it a fluke? No, it is not a fluke. This is actually the problem with tessellation. So I mentioned that in Alias and in other CAD software, tessellation happening in real time. So underneath the stuff we see, there is a math representation of polynomial. In it, in real time, tessellates converts to a mesh. And in this process, there is an issues. You know, there is a lot of algorithms humanity did, and most of them are flawed in one way or another. We are not perfect. Our algorithms are not perfect as well. So the reason why in this specific situation we have the issue is because the algorithm which we are using, it's not the Catmull-Clark, by the way. It is a different one and depends on the kernel and the tool you use. The algorithms are different. I believe they don't have any commercial names. They built within the company itself, but they all share the same similarity, is that these tessellators, built-in real-time tessellators in the CAD systems, they operated based on the curvature of your surface. So the smaller value of curvature you have, the less geometry it will bring. The more curvature it will have, the more geometry it will bring. And as I said, it's basically universal. Now the details can vary. I don't know how the actual code of the algorithm, but it's kind of kept secret. It's very specific to the company. So, but the issues like that you can spot everywhere, not only in Alias, in Rhino, in NX family, in in ICable, you name it. So the specific reason for this issue, as I said, there is just not enough curvature to operate with to properly tessellate. So I can predict that what happened here is that the surface is curved only in one direction, is we have a lot of polygons in the, let's say, I don't know, is it a U or V direction, doesn't matter, in one direction, and very little in another, which means that we're gonna see these lines where the Boolean operations happened. And as you can see, I have a Boolean operation here, and I basically cut this surface with a cylinder. And actually, we can easily visualize what's actually going under the hood and what structure it has. And for that, we have a tool which converts the current visual representation, the current, not visual representation, the underlying structure which we have right now, to the mesh, not in real time. I basically bake it to actually have the actual mesh with no link to the underlying structure. And to do so, actually use the hotkey Ctrl F. I believe it is a universal hotkey. It should work for you regardless what kind of hotkeys you changed everywhere else. And I will type NURBS, and that is NURBS to mesh. This is the one we're looking for. So I will double click on it first, and as you're gonna see, we have some parameters here. Now, first of all, we have an option called Use Existing Tessellation. What it means is that it takes the same parameters as you're gonna see right now, and then it converts, finalize it, bake it to the mesh, breaks the link basically. And this is exactly what I really want to do. So I will select my model. Oh, sorry, I didn't select my model. I select my model, and then I will bake that. I actually baked with the different parameters. Sorry, I forgot to check it. Okay, let me do it again. For some reason, just still not doing it. Let me just. Oh yeah, now it did it. Okay, so now I have the same. Basically tessellation as it was here originally. I mean the same structure, and now you're gonna see that I actually forgot to make a couple pieces here and move it all together, and this is a different question which we will address today, but you're gonna see that the reason why we have these issues is because our edges are too long. So you can see there is no additional supportive loops to our tessellation. This is a big issue. Why it is a big issue? Now, if you can think about that. If you want to take this piece and, for example, toss it to some CNC machine, and you want to just cut a hole in a metal piece, it doesn't matter how it looks. It has this issue, it doesn't have an issue. The underlying structure is the only thing. The polynomials are the only thing this machine will take. But in the situations where you need to visualize the stuff, you need to render it, you need to unwrap it, you need to paint it, you need to texture it, you need to render it for a cinematic, for commercial, for a still, it doesn't matter. This issue is a big issue because it will be tossed to because of the type of the geometry we have, and it will cost you. It will be just a pain in the ass because there is no way to really fix it at this point. Now another issue you may get is when you 3D print. Now the 3D printing, at least what I know, there is no 3D printers on the open market which actually operates with the NURBS geometry. They always operates with a discretized version of it, which is a mesh. So all the issues you have in your mesh, like what you're looking at, will be transferred in one way or another to the your 3D printed model. So this is another issue which you can get. But we are mostly focusing on visual right now because this is, that's rough. That's rough. So let me show you another examples before we go to the ways how to solve it. So there is another example. Now here I have two circles and a transitional surface with the curvature, and if I will, not this one, if I will activate my default shader once again, I will zoom in and I will see the same issue. So these visual issues may be more or less prominent, depends on the curvature of your model. Once again, it curves only in one direction, and in this one it's flat. That means that we don't have enough supportive edges to fix it. Now we have issues like that. Let me go to the next one. Okay, this one. So if I will activate it, it will be just fine. It's already. Now there is no issues here, and the reason why there is no issues here is because there is no curvature. It's just a flat piece. Now the moment I will try to move it, let me see, a little bit more. Yeah, we starting to see the same issues. Once again, it can be maybe more prominent in the viewport of Alias or less prominent in the viewport of Alias, but it will exist. And in the actual modeling tool like Blender, Maya, so on and so forth, it will be really, really prominent. It will look like an error. And in fact, it is an error, right? All this stuff is not great. Now, imagine, see what happened when I take this side. You know, it's curved in one direction, and I will curve it here. Oh, look at it. There is no issue anymore. Well, why was that? Well, now it's curved on the both sides. Remember what I said, a tessellator works based on the curvature. The more the curvature you have, the more triangulation it will bring. The more faces, the more edges, and the more complexity overall. So now, as you can see, the issue is gone. Now let me go to the go back to the original example, to this, or not to this one, sorry, this one, and I actually do here the same stuff. So because it's really prominent here that we have an issue. So if I will take these row of CVs, let me just kind of position the camera the way it's really visible, and I will just push it up. Oh, it's gone immediately. I'll go back, it appears. I go up, it disappears. You see? Now that's because, as I said, it works based on the curvature. Now, how we can solve this? Now that depends on what do you mean solving. If you want to make our models look more accurate and pleasing in the viewport of Alias, the only thing we can do, or the one thing we can do, is we can go in and click on in the shader on the option called Limit Edge Length. So basically, it limits the edge length to a very specific length. So that's right now much. The edge length is 1. I believe it is a 1 millimeter, and it means that now, independently on the curvature, it will still create the loops all around the model with the step of 1 millimeter. And immediately, as you can see, the issue is gone. And the same example here, we have our issue. Once again, I'm really sorry, guys, if this is really difficult to spot on the YouTube with YouTube compression and stuff. But yeah, here they are, and I will go and just select the object, click on limit edge length, and as you can see, it just goes away. And you may say, well, then that's nice. Is that it? We done? Well, no. We fixed the issue on real-time tessellation approach, which Alias has specifically. But when we decide that we're done with our model, I will actually use this one as an example because it's really simple. So when we decide that we're done and we actually want to use this part and export it to our 3D software package of choice to unwrap and texture and render, then this limit edge length is not really that helpful. Now, first of all, there is two ways to export your geometry into the other CAD softwares. And by exporting, I mean converting these NURB geometry. Once again, it just temporarily visualized, but at its core, it's still a NURBS data. And if I will save this file, it will not contain any information about, it will not have any tessellation inside. It will be only a math representation. And then open it up, it automatically starts and real-time retissellates me. Now, of course, most of the polygonal modeling software, if not all of them, are not doesn't really understand and work with NURBS geometry, except in Blender. It has some B-splines options, but not a lot of NURBS geometry, or NURBS curves they call it. But doesn't matter, I digress. So the proper way of doing it is to actually export this to the different type of file format, which actually tessellates and converts it to a mesh, basically baked it to the mesh, removing all the NURBS geometry data out and leaving only the mesh. And there is a few really prominent file formats. One of them is OBJ, another one is FBX. There is a difference between them, but for this lesson it's not that important. And there is the question, how are we going to do that? Now we have an issue. What will happen if I will export it using the alias? And as I said, there is a few options for me. One is using built-in systems, like when you go to File, Export, and Active As. These options are built-in converters, right? So they work within the tool. And the second variant is to use external tools, which help you with that. And I will tell you, just from the get-go, that for some reason, I'm starting to believe that this is some kind of maybe agreement between all of these CAD systems, is that their exporters are just horrible. All of them. Some people say, well, just the NX family with Tessellate kernel can do a great job. You know, people show you plasticity under the Tessellate kernel. Look how good it is. No, it's garbage. It's garbage. I don't know why. It's very sad because, you know, Alias is an extremely expensive tool. And when you have a low cluster exporting options with a shitty algorithm, it just makes me sad. But this is the realities of what it is. And once again, it's not only tied to the alias. I don't know any CAD system that actually has a good tessellator built in. So let me show you what I mean. I will just actually start to converting this into a mesh. I will show you all the issues so that you don't need to do that. And then I will show you the proper way using external tools. Okay, so let me just hit cancel. Now I will select the model I'm looking for. I'm looking at this one. And I would like to convert it to a mesh. So I go File, Export, Active As. I will change this to FBX. Scroll down, and as you can see, there is a surface tessellation. And I can click on Tessellate. There is a tolerance. The tessellator will be accurate. Now, mesh vertices actually doesn't really work properly. It's supposed to replace the stitching procedure, but in fact it doesn't really work that good, so just let it be. Yeah, that's pretty much it. Very simple, right? So if I'll go in and I'll click Save, and I will save it on my desktop, let's call it whatever it is, and I will open up my Blender. Let me actually delete the sphere. We don't need that anymore. And I will import these file using the FBX importer. Most of the CAD systems understand FBX. At least they can import this data. And I will import that. Here it is. Now, the first thing which you're going to notice is that these parts are separate. And this is a big problem. Why? Well, let me actually open up the structure here. So the problem is that these vertices are not connected. Let me just actually change the view to maybe Eclipse start to 001. All right, so you see here, there is a gap. There is a gap, it's basically a hole. Same here, you see, they're not connected. So the tessellators and the CAD geometry works within the specific tolerance. For the meshes, on the other hand, everything which is not connected, if the vertices are not connected, it's treated like non-manifold geometry. So basically a hole here, and it will impact the way how it looks. There is a hole, it will be visible. On top of that, the shading issues, of course, is just another thing. We have a really long stretches, you can see. Now it's transferred basically here. Well, what a shame. And this is not connected, and it just looks like garbage, and there is no way to solving it. That's it. It's you're done for. So let me just move it aside and go back into the alias and try to do a different method. So now, once again, I will select all of that. I will create image limit edge length. I'm sorry. Once again, limit edge length. So now it's supposed to have no issues whatsoever, right? And once again, I will select everything. I go to File, Export, and basically repeat the steps. And now I can click on merge vertices if I really wanted to. And then I will go and I will click on save, and let me save it to stage 2. Yeah, naming is quite bad, but it doesn't matter. And now I will import it back. So ABX, there is our new version. So if you open it up, you're going to see there is actually no difference. It's still not connected. Well, why was that? Well, that's because, well, thank Alias for that it just does this. So it's basically no difference. Why, right? Like, what's the problem? Now, the problem is that it doesn't really inherit the parameters of the tessellation, which we kind of have here. What are the alternatives? Well, one of the alternatives is to stitch the model. Now, we have a tool called stitching. Oh, basically, it doesn't call stitching, called shell, I believe, right? Yeah, it's called shell stitch. So what the shell stitch does, it's actually converting this collection of surfaces into a BREP. BREP stands for boundary representation. It is the same CAD data, it just basically combines all the surfaces together and use them as a collection. So basically telling the other softwares and the Alias as well is that this is the one group, or the one model, the one shape. They're not separate. So I can select this stuff. I will go to shell stitch, and I will go use construction options and stitch it, move it away, and now this one is a stitched version of that. Now let's try with this one. Go to File, go to Export, Active As. Once again, I'm doing all of these steps just to prove you that there is no right way of exporting it from Alias. There is a couple different methods in Rhino, for example, and you can get a slightly better result, but overall not really suffice for any accurate work, any good results whatsoever. So once again, this issue is not only Alias related, it's across all the CAD systems. So once again, I will go to export. Now this one will be stage 3. And let's repeat the steps. Let's import VX. Here we go. Let me just kind of push it away. Look at this stuff. Yeah, that's well, that's horrible, isn't it? It's even worse. So of course I can go in, I can delete the custom normal data, right? I can recalculate it myself, but you will never be able to create the proper result based on the structure. Just no way. So trying messing up with the normals will not help you. Cool. What other options do we have? Let's go back again. Now, the logical way of doing that now is when we have these object. Now, at least this is a one piece, right? So, by the way, in comparison, if I will take this one and I will zoom in, now you're going to see that at least the points are connected. Now, there is no holes. Well, thank you very much. Thank you very much. But this is not enough. I need to have the proper normals, right? So I need a proper structure. Now, what we can do is we can use the same shell, or basically the binary representation of our surfaces, and then I can go in and I will convert this, as we did before, to a mesh. Now I need just to actually delete this because this is too dense. Let's go to the tolerance of, I don't know, that was 0.01, I believe. 0.01, and the length, image length, the limit edge length, let's say that it will be a 1. Now let me try to do that again. Well, that's still very unmanageable. Okay, let me just make a different parameter here. Let's say that edge length will be 10. So just something we can work with. I believe it's better. Let's and the problem here, you already see the problem. I need to do it myself all the time. There is like this. Sometimes it works, sometimes it's activate, sometimes it doesn't want to activate. All right, well, here it is. Let's move that away. Well, this one is definitely better. We have a pretty big amount of geometry for this small piece, but at least it's something, right? And everything is connected, looks like. Let me just actually export that. So this is a mesh already. So I can go in and I will export that as an FBX as well. So we don't need to tessellate, we already did everything. So I'll go save, and I will save it to, let's say, stage 4. And then we'll go back in Blender again. What a horrible piece. And let me import that. So I know that this is very boring, guys, but yeah, this is what you will encounter yourself when you will try to do it. Okay, look at this stuff. Yeah, so the normals is still... yeah, well, at least it's connected. It's already a good sign, but the, yeah, this one is not good. Is there any other options to bring this stuff that it looks fine, it will be connected? Now, the last thing which we can try, the last resort, let me just kind of delete this stuff. We're going to select our model, and this time, instead of a merge type modeling, we change it to merge type visualize. And first of all, I need to delete this. So this is visualize, the max line. Let me just kind of make it 15 maybe. Like that. So select it and do it. Right, here it is. Yeah, okay. So now, is this better? Now let's try. Well, we are almost done here, so we'll go and save it to stage, let's say 5, like that. All right, now let's open up the Blender and import. And here we go. Where is it? Oh, here it is. Okay. Now, well, that's better, isn't it? Yeah, finally, we did it, right? We did it. Well, it definitely looks better than everything else. It probably will look quite nice if I will actually bring some shader here. Now, don't worry about these ones. This is the reflection of these shitty ones. Yeah, that's definitely better. But there is a catch. It is triangulated. Yeah, it is triangulated, which means that, yeah, good luck picking edges to mark the seams to unwrap your model. Yeah, good luck doing that. Now you will need to do it manually, kind of like doing it like this, you know. Oh, and I made a mistake. Oh no, I didn't. Here, nope, not here, here, yeah. And you will need to do it, and then there is like the stuff like this. Yeah, good luck doing that. We have an issues here as well, but that's not that big of a problem. So the problem is that it is triangulated. There is a lot of our extra geometry, and even though that for gaming engines is actually the way how it's supposed to be, and maybe one day I will make a video why gaming engines use triangulation. But for us, we always, the problem is that we always can triangulate. And I actually show it to you later, all the 3D software packages are really great at triangulating. So you don't need to tessellate with triangulation. Sadly, guess what? Alias can't tessellate without triangulation. Other tools can, Rhino can, NX family can. It doesn't really make life that much easier. Still, the result will still be shit. Well, Alias can do even that. So yeah, so that's better, but it's still unusable. Imagine that you have a really big model. Well, yeah, that's that's why some people say that it is impossible to unwrap the cut data. Well, that's because of these results. So let's go back. Now, what I want to say by all of this is that there is no right way to export it straight from the alias. And by the way, if you're watching this and you're like in the Alias 2025 educational license, you're out of luck because it doesn't have any exporting options because, well, it's just for learning, right? So the alternative method to trying to export it using native tessellator and exporting options within your software package, your CAD software package, the alternative, as I said, is use external tools. And in fact, this is the prominent way of doing that, because as for the tools, there are a few in the market. The most prominent one that industry use is Pixyz or Pixyz. I don't know how to pronounce it correctly. I will put a link in the description to this tool and actually show you this tool. I showed it on my first videos, and I will do it again here because this is one of the best. As I said, it's somewhat like an industry standard these days. But there are a few others like Hoops, Cutfix, Meshmatic, Polygonica. I believe you can find more just Googling them and try them out, but I will focus on Pixyz in this lesson. So one of the benefits of the external tessellators is that you don't really need to take your model and then stitch it to create a binary representation and then tessellate it, piece by piece, and then export this piece separately. You see how many steps you need to do to create at least somewhat a decent result like this one, right? So you need to go through these steps, and you need to do it for like everything, and your model may have thousands of pieces. So yeah, that's horrible. So when you have external tessellators, most of them are working within the groups, with your layer groups, and the Pixyz goes even further, and it actually gives you an ability to work straight with the wire files. Now the wire files are the alias files, so if I will save the file as it is, like this, it will save it as a wire file. Well, the Pixyz can open these wire files and operates with them and use their internal structure. Just to show you how it works, let me open up this tool. Here it is. I mentioned it before and I said it again. This is, at this point, at this current date, is the standard in the industry. You can take, Tesla, you can take NVIDIA, you can take any big industrial bureau. They all operate with the same stuff. BMW, Mercedes-Benz, you name it. All the Chinese companies, when you need to visualize stuff, they use the Pixyz Studio tessellator. Now, the Polygonica, as I heard, is pretty good as well, but I never tried it myself. Can't say for sure. So, how it works. So, and once again, I will put the link to this tool in the description. So what I'm going to do is I'll click on the guided import, and I will just select the file. And that's simple as that. Now, there is a guided import, there is a raw import, which we use when we really have a very intricate designs. I will not be touching that. There is a great documentation for the tool. There is a couple of videos. It's really easy to get a grasp. But right now, we will do it the fastest way and basically the good way. So, first of all, what I need to do is I need to change the custom values. Let's say to 0.01. My max length will be like 10 millimeter. I think it was 10 or 12. This is the based on the curvature, how many of the subdivisions we will get. I can reorient faces, why not? And let me just click execute. And as you're gonna see, it's just a magic. It just appears here without any stitching, exporting step files, none of that. It's just right there. And if I will open up its structure, you will notice that, oh, wait a second, it's triangulated again. Yeah, it's triangulated again, but don't worry, we easily can fix this. Now, first of all, it's already connected. So we have pretty much the same result without all of the shenanigans with stitching, manual conversion, then exporting. No. Okay, it's done. It's already here. So what I need to do, actually, let me, just for the sake of it, let me just reset the project and go to the settings. I will go to the tessellation. I will tackle the generate quads option. Cool. Now let me just import that again, and I believe that will be the same parameters. And yeah, here we go. Right. That is the proper structure you're supposed to have when you tessellate your cut geometry. Now I would say that there is a little bit too much of the edges, and I can easily retessellate it if I wanted to. So I can just go in and go to retessellate selection, and I will say, well, let's say like this. Bam. Easy as that. I want to go back. Bam. Execute. So, and there is so many different options. There is a way to make the Z buffer fixed. There is a lot of options to triangulation, there is a lot of options to voxelization, there is even unwrapping, there is a lot of good stuff. There is a lot of mesh repairs, there is additional console to run some scripts. It's a professional tool, let's put it this way. Now, when we're done, first of all, I'm going to see that my normals are wrong. So let me just go to the mesh and I will say orient faces and execute. Okay, now it's good. And I will export that, and I will export it as it was stage 5, let's call it S6. I think that's good enough. And I will switch that so it will be more uniform with the other examples to FBX. And I will save that. And then I will open it in Blender. So import. Oh no, this is the wrong one. I missed click. I missed click. Okay, here it is. Right. Okay, now that's working. It even marked my edge as a sharp edge. That's always useful. So just a great solution overall. And if I really wanted to triangulate this piece, let me just kind of duplicate that. I can always do that, right? So I can go in and just triangulate this geometry into the, it doesn't matter how much, let's say here, enough. And it's ready for the gaming engine. Now, of course, before that, you need to unwrap and yada, 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 but this is the way to do. Now, as I said, the Pixyz is not the only tool you can use. And there is a few others, as what I tried the Cutfix, and it's pretty good, and Polygonica, I never tried, but people said it's good. Hoops is pretty good as well. What I will encourage you is just not use the standard built-in functions of Alias. And I heard that in 2025.1 they made some adjustments to the tessellation, to the exporter, and I checked it out, and no, it still runs like shit. So don't use it. If you're working with Alias, do not use built-in exporters. Use only external exporters. Right. So as a conclusion, all your NURBS data, everything you see, represents in a viewport as a mesh through tessellation process. A tessellation defines how your NURBS geometry will be presented, and all visual issues you have in your models are tessellation related. The best way to tessellate your NURBS data is to use external tessellators instead of built-in ones, at least at the time of recording. And the tool I suggest is Pixyz. It is expensive, but it delivers. That's it. Thank you very much for watching, and I will see you in the next one.